ay plus bx minus by. So if we take ax and ay, the two first terms, we see that we have a common element a between them, and in the two other terms bx and by, we have the common element b. Okay, so if we take this first element as a common, a into x minus y plus, and in the secondary grouping, if we take b into x minus y. So as you see here, we get an expression formed of two terms. The first term is a into x minus y, and the second term is b into x minus y, separated by plus. Between these two terms, or these two blocks, we have a common. The common is a common factor, x minus y. So here we have x minus y as a common factor between these two terms. So we take it as a common factor into, from the first block we get a plus, here from the second block we get b, and this is the factorization of the expression b. Passing to the other expression c. So c equals y squared minus 2z plus yz minus 2y. If we take the two first elements, we don't have any common between them, between y squared and 2z. But if we take y squared and yz, we have a common y. And 2z and 2y, we have a common 2. Okay, so here we want to regroup these elements. So we can write it like this. C equals y squared. We put beside y squared plus yz. Don't forget, we take the element, we can change its place, and we take also its sign. Its sign is on the left of the term. So plus yz. Then minus 2z minus 2y. So here I make a regrouping of these elements. So C equals, between the two first elements, as you see, we have y as a common element. So we take this common element with the less power, y, into, from y squared, the remainder is y, plus from yz, the remainder is z. Now, from the two other elements, minus 2z and minus 2y, we can take minus 2 as a common. So minus 2, from minus 2z, the remainder is z. Now pay attention, minus 2y is like plus minus 2y. So when we take minus 2y, or minus 2, the remainder is plus. So here minus 2 and here minus 2 are both going to a common member in the beginning of the parenthesis here. So the remainder from minus 2 is plus y. Now, as you see, we have now two blocks separated by minus. Between these two blocks, or two terms, we have a common factor now, which is y plus z. We take this common factor, y plus z, okay, into, from the first block the remainder is y, from the second block the remainder is minus 2. So this is the factorization of C. we continue to the part D. Okay, here the first block is x squared plus b plus c, and then minus b minus c. So the only thing that we can do here, okay, we leave x squared into b plus c because it's in the factorization form, but between minus b and minus c we can take the minus as common, minus. Okay, minus b صارت b and minus c صارت plus c. So if you do the expand again, you get minus b minus c. Okay, so we return to the main form. Okay, so now as you see, between these two terms we have a common factor b plus c, so we can take this common factor d equals b plus c into, from the first block the remainder is x squared, from the second block the remainder is minus 1. Now pay attention, we can continue our factorization because in the second factor we have x squared minus 1. It's a factor contains two terms, x squared and 1 separated by minus, but 1 we can write it as 1 squared, right? So here we can apply the identity that, say, if we have a squared minus b squared, we can write it as a minus b into a plus b. Don't forget this. So b plus c here, d equals to b plus c into x squared minus 1 is x minus 1. We apply directly the identity into x plus 1, and this is the factorization form of d. Now for the part E here is equals to 3x squared minus 12x plus 12. Here we cannot make the regrouping, but as you see between the three terms here we have the number 3 as a common, so we take it. From the first term we get x squared, from the second minus 4x, and then plus 4. So inside the parentheses, as you see, we have three terms, x squared minus 4x plus 4. So E equals 3 into. Now we should think about the identity here, a squared minus 2ab plus b squared, which is equal to a minus b squared. So here x squared, a is x, it's under the power 2, and minus 4x we leave it, plus 4 we can write it as 2 squared, so we get here b, it is under the power 2, it's equals to 2. Now we test if in the middle we have minus 2ab. Okay, minus 2ab equals to minus 2 into x times 2, so equals minus 4x, and this is minus 4x. Yes, so it's of the form a squared minus 2ab plus b squared. So okay, I continue here. E equals 3 into a minus b, a is x, this is x, minus b minus 2 at all squared, and this is the factorization of E. Now f, here f is x3 minus x plus x minus 1 into x plus 3 into x plus 1. Pay attention, students. x minus 1 into x plus 3 into x plus 1, this is for one term. This is a one term because they are a product. So f equals, between x3 and x, we can take x as a common. We get x squared minus 1 plus x minus 1 into x plus 3 into x plus 1. So now f equals, and as you see here in x squared minus 1, this is the third identity. 1, we can write it as 1 squared. So it's a direct application of the third identity, x minus 1 into x plus 1, right? Plus x minus 1 into x plus 3 into x plus 1. Now we get two blocks. The first block is x into x minus 1 into x plus 1, plus separated by this plus here. And the second block is x minus 1 into x plus 3 into x plus 1. Between the two blocks, as you see, we have x minus 1 and x plus 1 as common. So we take this common, f equals x minus 1 into x plus 1. Now we open our parentheses. From the first block we have x, this is a plus. From the second block we have x plus 3. Okay, so finally f equals to x minus 1 into x plus 1, and to reduce the third parenthesis, so it is equal to 2x plus 3, and it's done. Okay.